Our next question. We need to find the integral of this continuous function. Xt. This is the value of x of t. This is the value here. Then this is the integral function starting from -1 to 6. Okay. This is a unit step function. Okay, so this is the integral that we have, and there is one formula. Before we do anything, we need to check the range that we have here based on the integral interval. Okay, how are we gonna do that? Before we start, there's something that you need to know. Okay, this is the formula that we'll be using. Okay, and what does it mean? I'm going just to show you with a drawing. Okay, this is a unit pulse. Sorry, a unit step function based on that formula. This formula the meaning of this formula is, I'm going just to draw it. Okay, what you see there, this is where we have the amplitude of our unit step. Everything here, this is where we have negative infinity, and this is where we have positive infinity, and here we have 0. What we're saying is we're only gonna consider everything that is positive. Okay, and then we're gonna reject everything that is negative. See, I'm gonna reject everything that you have this side. So that's why you see we gonna use this formula along the way. Now I'm gonna show you where we're gonna use it. Okay, so now we're gonna check now, and when we start, I'm gonna call this one as case 1 just to make it easier for us. Case 1, case 2, case 3, case 4. Okay, so let's start with case 1. And before we do, there's one thing that I need to do now. Okay. We're gonna add this later on. The first thing that I want to do, I want to maybe write this equation in an easy way where we can see what is inside this integral. So here it's gonna be 2 integral -1 6 u of t plus 5. Okay, this is how our integral is going to be. I see that we're gonna use this structure here, so let me just copy this block. Okay, and this is what we have from this is what we have for case 1, case 2, and here case 4. Okay, so now we're gonna check the interval. If this formula here it's correct, this is what we're gonna check now. So what you're gonna do here, I'm gonna take case 1 here so that I can work out case 1. And what was the integral? It was 2 6 negative 1 u t plus 5 dt. Okay, we need to check for t. If t equal to negative 1 and if t equal to 6, and then where we gonna check this? Inside this unit step. Check if the unit step is that inside the range. So this is the unit step that we have here. U plus 5 equal to u unit. The empty space is for the value of t. So what is the value of t? Negative 1. And what is the value of t? Is 6. Negative 1 plus 5 is going to give us 4. 6 plus 5 is going to give us 11. As you can see, the rules is t has to be superior or equal to 0. This one is valid and this one is valid. So the first case, everything is fine. Let's go and try case 2. And try out case 3. 2, 3, and 4. So this is case 2. Where's the... Okay, this is the equation for case 2. Now, we need to check if we're gonna find this integral in this range. Okay, so what you're gonna do here, we know that it's gonna be u of t plus 3 for this case. You see what you have here. So t equal to negative 1 and t equal to 6. So t1 and t2. It's gonna be u plus 3 equal to unit. Okay, negative 1, 6 plus 3. Negative 1 plus 3 is going to give us positive 2. 3 plus 6 is going to give us 9. So these two are correct. So which means case 2 is also correct. So now let's go for case 3. Okay, this is what we have on case 3. We need to check if this rules is correct. So this is what you're gonna use here. U t negative 1. Okay, t equal negative 1 and t equal 6. Okay, u of t negative 1, u of t negative 1. What is the value of t? Negative 1, 6. U negative 1, negative 2. So I'm gonna put just an empty space so that you can have some color in between. So negative 1, negative 1 give us negative 2, and then this one's 5. So now you see here, this one is correct and this one is incorrect. What we're gonna do here, and just to make it easy to see, I'm gonna just move this one and the bottom so that I can have can modify it easily. Okay. Okay, so what is going to happen here? If you look here, we need to check. Okay, we need to make this one to be equal, because the lowest point in this block. So we start from t equal to 0 all the way to t equal to positive infinity. You see? So we need to make it equal to the lowest, because negative is this side. This is where we have negative. Negative t is the other side. So we need to take the first positive value. How are we gonna make it equal to the first positive value? This is when we're gonna now. What is the value of t? If you want t to be equal to this unit step to be equal to 0, the t value to be equal to 0. I know that if I put 1 here, then it's gonna make it equal to 0. So if t equal to 1, unit step is gonna be 0, -1, which 1, -1, it's gonna give us unit of 0. And then now you can see that now we're getting something positive. So we're gonna change this into just second example. So what's really happened to our integral? We're gonna rewrite this integral. It's better if only the interval are seen. Okay, dt. So what about the integral values? Okay, here we have 6, so we're gonna have 6 here. 6 because 6 verified when we try to fix 6, but when you try 1, -1 doesn't work, so we use +1. So now I'm gonna put here +1. So you see now how this integral is for case 3. So let's go for case 4. Okay, and this is case 4. Same formulas. Now we need to check if this block is correct. So it's u the t -5. Okay, and t equal to 6 and t equal to -1. Okay, so what will happen here? So u of t -5 equal to u of what? Unit step, unit. So we will change as the value of t. 6, -1, which give you 1 here, and then -6. Okay, this one is negative and this one is positive. So now we have also noticed that this one is correct and this one is incorrect. We need to change it. So how are we gonna change it? We need to make it equal to 0, because we see that we're gonna start. This means we start t equal to 0 all the way up to t equal to positive infinity, and everything that's come before here it's not valid. So we need to move the interval to t0. So we need to move from negative to t0. Like here we have negative, we need to move from negative to t0. So in order for me to make t the unit step here to be equal 0, I need to change the value of t. So I think it should be 5. -5 is gonna give you units of 0. Now this is what you have at this side, and then what is the value of t equal to 5. There we go. So now this integral is going to change. You're gonna write it 3, 6, since 6 is valid, negative 5 dt. So what is the value of negative 1? We change it and we found 5. There we go. So now this is what we have on case 4. This is what we have on case 4. Okay, so this is what we had as integral when we first started. Now these are the integral that we got case 3 and then on case 4, and this one is verified, so we don't need to change anything. This one verified and this one didn't verify it, so that's why we change the interval on negative 1 this side. All right, so then what will happen here is we're going to integrate this whole equation. So what will be the final what will be our integral? Our integral will be like this. Case 1, 2 integral 6 negative 1 dt. Okay, plus second integral t plus 3 dt. So since we already checked and verified that it's correct, so we don't need to write this thing inside anymore. So negative 2 6 negative 1 dt, negative 3 negative 1 6 dt. You see, and the integral for this function, and the answer is 22 if we do the integral of this equation on the calculator. The answer is 22. Okay, and our answer is 22. That is our final answer.